Once we have our angles recorded, both face left and face right at each of the instrument stations, we're now going to calculate the difference between the two face left angles and the difference between the two face right angles. So what I mean by that is that we're going to calculate the difference between 89, 12, 0 and 0, 0, 0 and write in the difference in the cell beneath. For the first pair, the difference is 89, 12, 0. Likewise, repeat for the pair of face right angles. The difference between those two is 89, 12, 20. The difference going in underneath. Then for the pair of the two angles, we're going to calculate the average of these two and write it in the cell immediately after. 89, 12, 0 plus another 89, 12, 20. Add them together, divide by 2, and you get 89, 12, 10. Repeat the process for the set of angles at station B. Work out the difference between the two face left. Work out the difference between the two face right. Then take the average of the two face right or two angles and place it under the mean horizontal angle. In this case, we get 90, 59, 30 and 90, 59, 45. The average of those two angles is 90, 59, 37.5 minutes. Repeat again for the set of angles at station D. Work out the difference, place the difference beneath. Work out the difference face right, place the difference beneath. Then work out the average angle and place it under the mean horizontal angle. Here we get 90 degrees, 15 minutes and 5 seconds, and 90 degrees, 15 minutes and 0 seconds. The average of these two angles gives you 90 degrees, 15 minutes, 2.5 seconds. Now repeat for the set of angles at station C. Work out the two differences, place it beneath. Work out the two differences, place it beneath. Then take the average and place that under the mean horizontal angle. Here we get 89, 32, 50 and 89, 32, 55. The average of these two angles is 89, 32, 52.5 degrees. We can fill in under column 7 the angle reference that these relate to. So angle BAC, we have in this case angle DBA, angle CDB and angle ACD. In our closed traverse, we have 4 points or stations. if our measurements for angles were 100% correct, station A, B, C and D, our 4 angles that we've measured should add up to give us 360 degrees. For our 4-point traverse, or for any traverse, the sum of the total angles is given by a simple formula of n minus 2 times 180, where n refers to the number of sides. So in our case, we have 4 sides. 4 minus 2 times 180. 4 minus 2 gives you 2 times 180 gives you a total internal angle of 360 degrees. If we look back now at our 4 mean horizontal angles, if our measurements were correct, these 4 mean angles should add up to give us exactly 360 degrees. However, whenever we complete our total calculation, so adding our 4 angles together, we actually get a total value of 359 degrees, 59 minutes, 42.5 seconds. Working out the difference between our total angle and the angle we should have gotten, which was 360 degrees. So 360 minus 359, 59, 42.5 gives us a difference of 0 degrees, 0 minutes, 17.5 seconds. In our measurements, we're going to take the total deviation and divide that by 4 because we have 4 stations, and the correction that we would apply to each of the stations will be 0, 0, 17.5 divided by 4, which will be 0 degrees, 0 minutes, 4.38 seconds. This value for correction will be added to each of the 4 mean angles to give us our corrected mean horizontal angles. If the correction value is correct, then our 4 angles, once corrected, should add up to give us 360 degrees exactly. Adding our correction to each of the mean horizontal angles, we get 89, 12, 14.37, and we get 90, 59, 41.88 seconds, 90, 15, 6.87 seconds, and finally 89 degrees, 32 minutes, 56.87 minutes. Adding together our corrected angles, and indeed it does give us a total of 360 degrees, 0 minutes, 0 seconds. Our angles have been corrected and are corrected to give the correct total. Now looking at the distances, we have measured each of the 4 distances twice. So for each of the distances, we're going to write down the 2 values we have and take the average. So at the very bottom, we have the distance. So the first distance we're going to do is the distance A to B. For that, we have measured the distance twice at 47.596, and laterally we had a second measurement of 47.596. Work out the average, and that will give us 47.596. These distances A to B, there was one, A to B, and there's the second one. Next one we're going to look at will be the distance B to D, which is at 21.082 and another 21.802. Fill our values in. Work out the average, and we get the same value. Next, we're going to look at distances C to D. Distances C to D, 47.672, 47.674. You'll record these 2 distances. Work out the average, and we get 47.673. Finally, the last part of the traverse, distance A to C, we have 2 measurements, 22.107 and a 22.105. Work out the difference, or work out the average of these 2 values, 22.106. These 4 distances are what we're going to use in subsequent calculations. For measurement of the bearing angle, we're going to do that in a slightly different manner. Here I'm just going to state the value that I'm using. So at station A, using a compass, looking at station B, our bearing angle that is recorded is 100 degrees, 30 minutes and 0 seconds. This bearing angle will be used in our next video, which is plotting out the results.